torque. What's that? The door? Okay. Oh, yeah, that's right. Talk about the door and all that stuff. Okay, so torque, remember, is the cross product of force times distance. And this force times distance, this distance means from the point of rotation to the point of force applied. What does a cross product mean? For you guys, it means nothing more than FD sine theta. Okay, so if you have like a person out on the diving board, so if you have this person out here, and whatever the diving board's connected like this, if this system fell apart, where would it pivot? Like, can you imagine this thing falling? Like, I don't know, whatever, the bolts rusted through or something. That actually happened.
Try using brakes from the ground.
Okay, well, I mean, if it broke from the ground, it would pivot here, right? And if it broke up here, it would probably pivot right on this edge, right? So now the cool thing about torque is that it doesn't matter where you put the pivot. Like, everything will work out as long as you're consistent, okay? So all I'm trying to do is get you to see, do you see that this can pivot around some point? Okay, so if I take this, okay, right now, can you see that this guy's weight is all through this one bucket? Well, if I put it there or the other, it's like into both. But how could you make this pivot? Like, just like the diving board, you could see it pivot. If this system fell apart, if something went wrong, would it pivot? How? Yeah, just grab one of the buckets and yank it away. See, and then this is going to pivot like that. Does that make sense? Okay, so remember, like I said, it doesn't matter where you put the pivot. Put it wherever you want. Before I do that, do you see that there are, let's say that this board has a mass. There are I heard my phone. There are 4 forces in this. What are they? The guy, gravity of the board, the normal force of what? The 2 buckets, right? Does that make sense to everyone? Right? So this is like FB1, this is FB2, this is F of the person, and this is F, well, let me see, stuff so you can figure it out. Have I lost anybody on this? Okay, so now, just because, now here's a note about the pivot. Put the pivot at a force, or 2. Put the pivot at a force. I just told you, where do you have to put the pivot? Anywhere you want, right? So, if I put the pivot at the point of a force, what does that do? Why? Look at torque. Torque is force times what? What is the distance from the pivot if the force goes through the pivot? 0. So what we've done is we've canceled out this torque. There is no torque, right? If you push a door on the hinges, will it open? Never, right? Unless you rip the door and the frame out of the wall, you will not go onto the other side, right? Even if you push 1 inch away from the pivot, 1 inch from the hinges, can you get the door open? Yes, but you have to push ridiculously hard. But you could still get it to open. Do you understand what I'm saying here? Does that make sense? Okay, so now I can make, and that's sum of the y, and it's 0. Because is anything moving? Are the buckets throwing this guy and the board up in the air? No. Okay, so we're going to say FB1 plus, well, that's great, FG. Now, is that enough? Even if I know the mass of the board and the guy, is that enough to finish? I still have how many unknowns? Do you see the 2? I have 2 unknowns. I don't know either of the buckets, the force of the buckets. That's where I now have to bring in torque. And over here we did sum of the force. Guess what we're going to do over here? Sum of the torque. Sum of a torque. All right, so we're going to use some sum of a torque. And now I want to draw these torques out. And remember, torques don't go up, down, left, right, positive, or negative. They go, what direction is this?
Clockwise.
Clockwise. Counterclockwise. So we're going to say that the clockwise torques equal the counterclockwise torques. Yep. And that's how I phrase it, whatever you want to do. And so what are the clockwise torques on here? What is trying to make this rotate clockwise around that pivot? Gravity. There are two of them, and the guy. And of course, those two. Yes. This one, the normal force of the bucket. And again, how come I didn't put in the bucket 1? Yeah, because it's 0. It goes through the pivot. So now I can say the clockwise would be the torque of the person plus the torque of gravity on the board is going to equal the torque of B2. There's Miami colors for you. Go Canes. Huh? Yeah, the U. It's not what Tallahassee's gold and red. Seminoles and Gators are blue and orange, I think. And we're assuming that they're perpendicular, right? Because I set it up already to be perpendicular. So I'm going to get FP, and then what I needed to do is give some distance. So let's say that this guy is L over 3 from this edge. So it'll be that times L over 3. Yeah, I just made that up. Given. Okay. Then we would say FG times L over 2. Now, I did not make that up. Because where is the mass of a board located? Ooh, the mass of a board is located in the middle. Now, that's obviously a silly statement because you'll be like, wait a minute, mass is located in the board. But in order for us to do calculations, we locate the mass at the center of mass, right? At the point in which, when you push there, then that object translates, it doesn't rotate. Yeah, it depends on how you look at it. But it's always the middle of a uniform board. So we put it there. And then that's going to equal FB2 times L. L is the length of the board, yes. And now I can cancel the L's. And so that gives me FP over 3 plus FG over 2 equals FB, yeah, just FB2. Do you see now I have two equations? With two unknowns, I can solve. Take this, substitute it in there to get FB1. Okay, and that is your, like, a standard